So let's pick this up right where we left off. We had to solve for x. So what we first did is we distributed this left-hand side. So we multiplied 1/5 times 2x. The 1 times the 2 gave me 2 over 5x. Minus 1 times 10 is 10 over 5. And we divide, we get negative 2 plus 4x equals. Distributed this side, we got negative 3/5 x minus 12. So now we need to combine like terms. So I'm going to go ahead and highlight some of these like terms here. So I've got x's on that side. So let's go ahead and combine those. So when I combine those, I'm going to end up with 4 2/5 x minus 2 equals negative 3/5 x minus 12. So I'm going to add the 3/5 x to both sides. And 2/5 plus 3/5 is 5/5. So that's a whole. So 4 plus 1 would give me 5x minus 2 equals negative 12. I can add 2 to both sides. So 5x equals negative 10 and x is equal to negative 2. All right, last one for this standard. How many solutions does this equation have? Remember, before we figure that out, we need to distribute. So I end up with 6m minus 12 equals 7m minus 4. At this point, we should know the m's are not going to cancel out. The sides are not equal. So that means if I were to solve this, I would get m equals some number, which means I have one solution. All right, moving into our last standard covered on our interim assessment. For each graph, identify the solution graphed. All right, so when we identify a solution, all we're looking for is where those lines cross, and they cross at negative 2, up 4. So negative 2, 4 would be my solution. My explanation is because that's where they cross. In the next one, these lines do not cross, so they do not cross, making them parallel, meaning they have no solution. All right, so we're going to solve each of these systems algebraically. That means we're either going to use elimination or substitution. So when we use substitution, we're literally going to take what y equals in one equation and plug it in for the other. So x plus 5 equals 3x minus 3. We can solve for x. X minus 3x is negative 2x plus 5 equals negative 3. Subtract that 5 from both sides. So x is equal to 4. Remember, when we solve systems, we need an x and a y. I am going to take that happy x value, plug it back in, so y is equal to 4 plus 5, so y equals 9, making my solution for 9. All right, in this system, you'll notice that y is not isolated like it was in the first one, but I can isolate it. I could isolate it, or I could use elimination and make a variable cancel out. So if you look, I have a positive 8y and a negative 2y. If I were to multiply the top by 4, I would have a negative 8y and a positive 8y, which means I can get that to cancel out. So I'm going to multiply 4 by that top equation. And again, that's because I want to eliminate a variable. We distribute that 4, so 4 times negative 2y is negative 8y equals negative 4x plus 28. I'm going to rewrite that second original equation. And something weird is going to happen here. So my y's cancel out. And it actually looks like my x's cancel out. So because of that, there's no solution. And in the last one, let's go ahead and look at the last one. This one looks pretty fairly easy with substitution. I'm going to take that and substitute it in. So x plus a negative 3x equals 16, or x minus 3x. So negative 2x equals 16. So x equals negative 8. And remember, we want to take that x value, plug it back in for y. So y equals negative 3 times x. We're going to plug in negative 8. So y equals 24. So my solution is negative 8, 24. Beautiful job. All right, so solve the system of equation by graphing. When we graph, remember, these are in the form of y equals mx plus b. M being my slope, b being my y-intercept. So I'm going to start with my y-intercept. My y-intercept is 5 in that first equation. From that point, we use the slope. That slope tells me to go down 2. So down 2 and over 1, 2, 3. I now have my 2 points, and I can graph my line. And I can graph my line that did not work properly. So I'm going to go ahead and graph my line. All right. Next equation that I'm going to graph, I'm going to start with my y-intercept. That y-intercept is at negative 5. So I'm going to go where y is at negative 5. That slope tells me to rise 4 in the negative direction. So I can go down 1, 2, 3, 4, and I'm going to go over 1. I could also go up 1, 2, 3, 4, and back 1. So I now have, I now have my line. It looks like I'm going to have to not do the drawing tool for this one. All right, and if I were to extend this other line out, we would see that these are going to intersect somewhere right around here, up 1, 2, 3, 4 over 1. Looks like they're going to intersect right about there. So there's my solution. So let's just double check here. Positive 5 up 1, 2 over 1, 2, 3. So it looks like they're going to intersect right about there, and that would be approximately, looks like negative 5, 10. So it looks like negative 5, 10. Maybe that's a little bit off, maybe -5, 9. I want to say -5, 9. And this is just approximate. We didn't graph it exactly, so that's just approximate. All right, last two real quick. A graph system of equations is shown. What is the approximate solution? So this graph is in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's in increments of 1. So this looks like it's about over 1, up 1, 2, 3, 4, 4, almost 4, 3.5. So I'd say 1.5, 3.5, because it looks like we went over right about here and up right about there. And the last one, a system of equation is shown. What is the solution? We're going to use substitution. We're going to substitute 10 in for x, so 3 times 10 plus 5y equals 20. So 30 plus 5y equals 20. Subtract that 30 on both sides. So y equals -2. We already knew that x was 10 and y is -2. Oh, all right. I don't know about y'all, but I just did all three of those videos very fast. That was exhausting. Hopefully you'll be able to preview these and answer some of these questions for interim assessment. Have a wonderful day. Bye, y'all.